Hello everyone, welcome back to the second video of this tutorial series of using the ROS-MCP server with n8n workflows. So in the first video, we looked at how do you set up your n8n as well as your ROS-MCP server running locally on your computer. We looked at how the installation would work, what are the steps involved in it, and we looked at the basic examples of this. In this video, we will be looking at one workflow that I have built using Telegram, when you can give commands using your Telegram bot to directly the robot that's being operated on the ROS-MCP server. So this could be running again on the Raspberry Pi locally, and you would be able to connect it using to your n8n, and you could be able to send commands directly to the Telegram bot over to the ROS-MCP server, and then that will itself be able to take actions and you'll be able to observe different states as well. Alright, so let's get started and I'll guide you. Alright, so this is the workflow that I have built. It uses Telegram as the main trigger and the interface for you to interact with the ROS-MCP client. And you can not just be able to interact with text, but you can also interact and send commands by your voice to the ROS-MCP server. So let's first see it in action on how it works. Alright, so this is a basic intro of how it works. Now let's try to see on how to set it up. So in case you've not already watched it, make sure that you do watch the first part of this video where I've installed the ROS-MCP server and connected that to n8n. And once you have that, we'll be able to sort of start working on the n8n node for us to be able to connect it to this, because there's no difference in terms of the changing of setup from there. It's just the commands that needs to be configured and done from there. So let's go on an n8n dashboard. So the first thing that you would need is you would require a Telegram bot. So you can come to Telegram and you will have to search for something called as bot father, and this will help us create our own custom bot for our MCP server. So although you can do it, but you can say you want to create a new bot and you can just say /new bot. This will ask us what the name should be. I will say just ROS-MCP and bot. So it has to be a different name. I will just name ROS-MCP bot. I hope this works, and it does. So it has given us an access token for this particular bot, which means that we'll be able to now authenticate this bot to an n8n workflow. So make sure that you now copy this particular token that you have and you come to the n8n workflow. So I'll give you a brief about the n8n workflow that has been here. So as you can see that this is coming from the last video that we did, where this AI agent has access to a chat model which is a O3 mini, which is connected to an OpenAI account and an API layer. And then this is the AI agent that I have, and this is taking in a prompt that's coming from Telegram, and this is a system message that I've given. I'll be giving this system message in the GitHub repository for this as well, and the max iterations have been set to 20. Alright, so the first thing that we need to do is that we need to come to the Telegram trigger. So this is the Telegram trigger. We'll have to set up a Telegram account. So I already have one Telegram account. This is the Telegram bot, but as I've created a new bot, I'll create a new credentials and I'll paste the access token here and I will hit on save. So this is actually the I will rename it ROS-MCP server, and I have renamed it and I will hit on save. It should now be able to trigger on message. So whenever I message something new on Telegram, the workflow should start executing. Alright. The next thing that is there is that you can not just send commands from as text, but you can also send command in voice as well. So that's what I've done with this switch statement here, where if the command that's been given is in the form of text, and if the text exists, reroute it to text. If it's a voice command, I've asked it to recommand it as voice. And if none of them defaults, in case you sort of send a wrong input, you can always default it to none, where we ask the user to start to send a message again. So once based on, let's suppose if they send a text, it will be rerouted directly to the AI agent where it gets connected, and it gets rerouted to the AI agent where it gets connected, and it calls AI method and then sends a text message response back. And okay, in case, so let's run this to see if everything's working fine. So we'll have to, everything's connected, so we'll have to make sure that this is also configured as well, where it's communicating to the ROS-MCP bot. Yeah. So if I send a text command, so I have my ROS running here on my virtual machine. So I will actually start a total sim node. So this will be the main interface that I'll be using to check the n8n workflow along to see if it's being able to communicate with my ROS node. So you can also use any of the robots that you have which are running on ROS, and it should be able to pick it up. In the past, we've tested Unitary Go-To as well as different examples along with it. This is Total Sim, and I'll ask it a simple command on. I'll come to my bot and I will search for my bot, which is this ROS-MCP bot, and yeah. So this is the ROS-MCP server bot I have, and I'll click on start, and I can start giving commands to it. So before this, I'll have to make sure that this is published. So I'll publish this so that it is listening to my events, and then what I'll do, I'll just give it a command, make the total trajectory, and as you can see that it has already given me a message that it has established a connection. So and this should have started communicating with the bot and start the workflow with the command that I've gave it. And as you can see that the connections have started to come in inside the server. And I can also take a look at the different workflow executions that have been happening. And as you can see that this execution is running right now. So as you can see that the robot has started to move in a square trajectory, that the command that I gave it. All right, so as you can see that it has made a small tiny square, but it does the job. So that's great. I think we should be able to see a message, and yeah, so we are able to see a message where the AI has told us that the command has been executed successfully after the job has been done. And I can come back to the workflow, and as you can see that the workflow has been finished. Yeah, as you can see that the workflow has finished, and from my message it was able to route it to the text protocol, and then call the AI agent, and there were some 3 calls back and forth, and it sent a text message back. All right, so now let's take a look at how do we use voice to command and control a robot. So we can use Telegram for it again, and I'll be able to use my voice for the same. Okay, so for the voice, I'm routing it to get the file from Telegram. So this is the node where I'm getting, so this is the Telegram account that I have, and this is the file that I'm getting from the voice ID. And then basically I'm using OpenAI's transcribe text model, and I'm connecting it and transcribing the audio that I have with the data. And then I'm sending a text message to confirm if the transcribed audio is correct and if the user wants to continue with it. And I think this is just giving the option to the user to continue or maybe restart the workflow again, because if in case it picks up something wrong, the MCP will not be able to understand what to exactly do. The user will have 2 options, which will be to either go ahead or it will be to start over. If he says go ahead, then we can send the same text message to the AI agent where it executes the workflow, or in case if it says to start over, we'll ask the user please send the message again. So that's it. Let's try to give it a voice command and see how it operates. So I will allow it. Hi, I would like to know what are the topics that are running currently on the ROS-MCP server and ROS, and then I would like you to move my robot in a star-shaped trajectory, as well as spawn an extra turtle and then move it forward and backward 2 times. All right, so I've now sent this command to this. Okay, so there has been an error. I think it probably has to do something with the file that I'm using. So I shouldn't be using this. I should be using this one, and I should change the bot, and I'll do that quickly. All right, sorry for that. I think there were some errors because I changed the bots. Now I've changed the credentials again to point to this particular bot that we've created. And okay, let's try to record a message again and send it to the MCP server. Let me know what topics are available on the ROS-MCP server right now, and I would like you to move the turtle in a star-shaped trajectory. Then I would like you to spawn a new turtle and then be able to move it in backward and forward 3 or 4 times. I will come on executions and see if it's working. All right, so I got the transcription with me that I would like to know what MCP in the total in a star-shaped trajectory, and I think this is good. So I would say that I would like to continue this, and I would just click on yes, and then great, proceeding with the workflow. So it should now start working on the communication part. I will open this again. All right, so I should be able to start seeing the workflow in action. As you can see that the requests have started to come. All right, so the robot has now started to move as well. It's made sort of a star, which is like a triangle or double triangle, but we'll give it to it. So now it should spawn another turtle before ending the request and make sure that it moves. All right, as you can see that it has spawned another turtle. Right, so this is great. So as you can see that this is the workflow that it had, and it was able to execute the commands that I gave. Now you can actually control your robot just from a Telegram bot, and that's great, right? So you can add on to these things, and you can add different nodes to this, and or even connect your own custom workflows on top of this. I will have the link to this particular workflow in the repositories of the ROS-MCP server demos, and you can make sure that you can use it from there, or you can build your own custom workflows on top of it. Thank you so much for watching the video. I hope you have a nice day. Goodbye.